All right, as promised, lesson 4, direct variation, YouTube video. So you only have to listen to me, unless of course you mute me. Okay, so this is the direct variation lesson. This is something you've probably seen before. A direct variation is when something can be written as a linear equation. It's going to make a straight line. Y varies directly to X is something that they will say oftentimes. And K in that equation there is a constant. No matter what X is, you multiply it by that same number, and that is how you get Y. That's why Y varies depending on what X is. Okay, so the first type of question you are going to see is this one right here. It's not even a question really so much as an example. It asks you, first of all, what's the variation, the constant of variation for the equation right here, which is -1/2. Now you'll notice not only does our line go through the origin because it's direct variation, but if you find our slope, which is down 2 to the right 4, and down 2 makes it a -2/4, which is -1/2. Our slope is the same as our constant of variation, and it will be, because that is how it varies. So oftentimes people will write our constant of variation as y equals mx as opposed to y equals kx. So in your book last year they used m because it is the slope of the line, but in this year don't be surprised, and that's what they're going to use, a k, because they're referring to the constant of variation. All right, so they're first going to ask you to graph some direct variation equations. When you see that, all you have to do for today and for now is make a t-chart. I would start with 0, and it should be 0. 3/5 times 0 is 0. Now with 3/5, be careful about what you put in there, right? I notice over here that my x only goes to positive and -6, so I'm going to go 5 and then -5. Why do I do that? Because when I take 3/5 times 5, it cancels out and I get 3. And if I take it times -5, I get -3. So here's my 0, 0. Here's my 1, 2, 3, 4, 5 up 3. 1, 2, 3, 4, 5, 3. And there is my line for that direct variation. The second one, which I'm going to graph right on here, x, y, 0, 0. Okay, if I put 1 in there, I get -4. Notice it doesn't even go to -4. So I'm going to go ahead and go backwards. If I put -1 in there, I get +4, and a -2, I get +8. So I have this one, and that one, and there's my line. Okay, pretty simple. Pick numbers to put in for x that will make y easy, or also that will make y be able to graph it on your graph. Okay, turn that paper over. Now the hardest part of direct variation is when they ask you to write an equation. Okay, you can do direct variation with a proportion because direct variation means it's proportional, but when they specifically ask you to write a direct variation equation, they're asking you to write an equation that looks like this, but with an actual number in there. Okay, so here's what it's going to look like. Let's look at example 3. Suppose y varies directly as x. So you know you have the equation y equals your constant times x, but you don't know what the constant is yet. Notice then they give you y equals -10 when x is 8. So we're going to take that given basically ordered pair, and I'm going to plug them in. So I'm going to get -10 equals k times 8. And now with that, I can actually solve for the direct, or the constant of variation. K is -10/8, which reduces to -5/4. Now I can rewrite the equation, which was their first question, which is just y equals -5/4x. That's the equation. Go on then and use that to find y when x is 14. So we're going to find y when we plug in 14 for x. So y equals -5/4 times 14. I'm going to reduce a little bit. So I get y equals negative 35 over 2. And if you wanted to make that a mixed number, you could. I'm going to leave it improper for now and move on. Okay? So 10 is the same type of question without all the wording, but be careful. Notice this one, they kind of flip it around. They said, find y when x is 1. Well, we'll get to that, but we got to write our equation first. Notice if y is 3 when x is 2. These two go together. So y equals kx, or 3 equals k times 2. If we solve for k, our constant is 3 over 2. Our equation is now y equals 3 over 2x. That's one answer. And now, let's find y when x is 1. Seems a little simple. Anything times 1 is itself, so y equals 3 over 2. All right, check out this one. It's, again, written a little bit different. If y is negative 5 when x is 2, those two go together. Y is negative 5 when x is 2. So negative 5 equals k times 2. Divide by 2 to solve for k. Our constant is negative 5 over 2. So our equation y equals negative 5 over 2x. Find y when x is 8. So we're going to take that equation. We're going to plug in 8 for x. Cross reduce, multiply, and y should be negative 20. On this very last one over here, be careful of these. Looks the same if y is negative 7 when x is negative 21. So we have negative 7 equals k times negative 21. And when we solve it, don't get in a hurry, because that is not 3, it's 1/3. Our equation y equals 1/3 x. But look what it says. What is the value of x when y equals 9? So we're going to substitute 9 in for y. And now we have to do a division, or in this case multiply by the reciprocal, multiply by 3 to cancel those out. And x is 27. So be careful. They don't always just ask for y. Sometimes they ask for x. Okay? With our word problems, you can honestly solve these word problems with a proportion. I do not care. But I want you to be able to write that direct variation up there too. So that's how I'm going to choose to solve these. Okay, a car drives 283.5 miles in 4.5 hours. Assume the distance varies directly with the time. How far will the car travel in 7 hours? So distance varies directly with time. Notice how I put d and t instead of y and x. No big deal. I have 283.5 equals k times 4.5. Oops. So when I divide by 4.5, you will get 63. So my equation is distance equals 63 times time. In other words, she's driving 63 miles per hour. Oops, sorry about that. And when I then say, oh, how far is she going to go in 7 hours? Our distance should be 441 miles. And that's how you solve that one. Could you have solved it with a proportion? Absolutely. But I just wanted to show you, you can solve it with a direct variation equation as well. Same thing for this last geometry question. The width of the rectangle varies directly to the length, so I'm going to write this. Okay. Down here, my width is 5. My length is 12.5. So when I solve, now typically I'd say leave it as a fraction, but I got a decimal inside of it, so I'm going to go ahead and leave it as a decimal, 0.4. So width equals 0.4 times length. If what is the perimeter when it's 15 inches long? In other words, my length is 15, so 0.4 times 15 equals width, which, if you punch that into your calculator, is 6. Now, careful, because that is not the answer that they wanted. They said, what is the perimeter? So we have a rectangle with a length of 15 and a width of 6 that we just found. So we have 2 widths and 2 lengths. So 12 plus 30. In other words, our perimeter is 42 inches. All right, you've got a green worksheet to complete. I hope this was good enough for you. I'm always here if you have questions, or you can rewind me and listen again. All right, have a great weekend.